So follow along here and let's see if we can get all these correct. Okay, so number one, we're looking at the cube root of 3x to the fifth, and our goal here is to write it in exponential form. Okay, so remember our exponential form, if we have something like this, x to the a over b, we can convert that to radical. It would be that b is the index and a is the power. So we can go from here to here and vice versa. So we want to go change this into radical form. Now, I don't have a single exponent here, I just got the 5 there. So I can put that 3x to the fifth in a parenthesis of its own and then raise it to the 1/3 power. That would take care of my cube root. Okay, and that would be enough to put it in exponential form. If we wanted to split it up a little bit more, then we could do it like this, where we give that cube root to both, or that 1/3 power to both of those. So it'll be 3 to the 1/3, x to the 5/3. And then that would be our expanded exponential form, I suppose. Okay, so number 2, same thing, we have this square root over everything. So that means we need to put everything in parentheses, like this. And then a square root is the same thing as a 1/2 exponent. Okay, so there's a little 2 that's implied there. We don't usually write it there just because it's implied, kind of like the 1 in front of an x sometimes. Okay, so now we're going the other way. We're going to write it in radical form. So I have here, I got x to the 3/5. So the bottom is the index, and the top is the power. So it would be a 5th root of x cubed. That's how we would write that one. And then over here, we got the 3/4 power. So 4 is my index, and then I have 3n to the 4th j. All of that on the inside is being cubed. Okay, that would be sufficient. We could, if we wanted to, take that that exponent and give it to everything. So it would be this. So 3 cubed is 27. And then n to the 4th cubed is n to the 12th because we multiply our exponents. And then we have j to the 3rd power. So either one of those would work. This one right here is a little bit cleaner than the original, or than the other one. Okay. So down to the i's, using complex numbers here. So for each imaginary number, indicate whether its value is I, -1, -I, or just a 1. So we have I to the 38th here. So you want to figure out what number closest to 38 is divisible by 4. Because remember, I to the 4th is just a 1. So every time we have an I to the 4th, it's just going to cancel out and go away. Okay, because 1 times anything is itself. So if we got I to the 38th, we know that I to the 36th power is divisible by 4. So that would just be a whole bunch of 1. That would be 9 ones there. So it would be 1 times 1 times 1 times 1 times 1, 9 times. Okay, but we started with I to the 38th, so we also need an I squared, because that would maintain the problem. So these are just going to go turn into a 1, and then the I squared is a -1. Right? Because I times I is I squared. That would be a square root of -1 times the square root of -1, which is -1. Okay? So number 6 over here, we have I to the 63rd power. So I know that I to the 60th power is divisible by 4 evenly. So then that means I must have I to the 3rd left over. Okay? That's going to turn into a 1. So I got I to the 3rd. And we got to remember what I to the 3rd is, because we want to simplify this down to one of these. This up here doesn't say we can leave it as I to the 3rd. So I know that this is I squared times an I. Well, this right here is a -1. So I cubed, remember, is -I. That's what it simplifies down to. Okay, and now we got some radicals down here below. So number 7, we want to simplify square root of 75. So if we don't have a perfect square, we got to factor tree it. So it'll be 5 and 15, and 15 breaks down into 5 and 3. Since it's a square root, we're looking for 2 of a number. So we have two 5s, which would give us a 5 in front. So it would be 5 square root of 3. That's what that would simplify down to. Okay, so we're going on to number 8 now. So we're looking for cube root of 8x to the 5th, y to the 8th. Well, I know that the cube root of 8 is just a 2. Okay, and then we're looking to take out groups of x's and y's. So we have 5 of those x's underneath there, like this. So remember, every time we get 2 of those, that gives us an x in front of the radical. So that would be x squared in front of the radical with an x left underneath there. And then the same thing with the y to the 8th. Okay, and actually we are doing a cube root here, so I made a mistake. So let's fix that. We're looking for 3 of a number. Okay, I had it right to begin with, and I started messing up. So cube root of 8 is a 2, looking for 3 of a number. So we got to circle 3 of those, not 2 of those. Okay, so that'll give us just a single x in front. And then that's going to give us an x squared underneath. Okay, so make sure you're paying attention to the difference between a square root and a cube root. Okay, I've seen us do that so far, and I just did it. It's kind of easy. Make sure you're double checking things. So I got y to the 8th next. So I can take 2 groups from that. That'll give me a y squared, which would take 6 of those away. So we have a y squared underneath. And I got to make sure I put my little 3 back in there, that index number. All right, that's what it simplifies down to. Next one, number 9. So we have a distributive property type problem here. We're going to take that square root 3x and take it into both of those. So when we're taking a square root times a square root, you're just going to multiply whatever is underneath the radical. So for the first one, I'm going to multiply 3x and 12x, which is going to give me 36x squared. And then I have a minus there. 20 times 3x is square root of 60x. And then I know that the square root of 36x squared right there, that's just 6x. Okay, I got to put my 60x here. This is just 6x. And then we got to break that 60 down. So let's do 2, 30, 2, 15. And I know that that 15 is just going to be a 3 and a 5, so I can take my 2's right here. So it'll be minus 2 square root 15x. And remember, we cannot do anything else from there because we have to have exactly the same radical in order to add or subtract anything. We can't put anything together there.